This video is the next video in the algebra set of videos, and in this video we're going to be looking at simultaneous equations, one linear and one quadratic. When given a simultaneous equation that has one linear equation and one quadratic equation, we use the substitution method to solve the pair of equations. To do this, what you'll do is, in the linear equation, you express one variable in terms of the other, and then substitute the value for x or y, or t or k, or whatever it might be, in the quadratic equation, and then solve this equation using the minus b formula or factors to figure out the value of one of the variables, substituting it then back in to the linear equation to figure out the final variable. And as usual, this is best understood by going through an example. An example 3.1 here, it says solve the equations, and we have x plus y equals to 7 and x squared plus y squared is equal to 25. The first thing we're going to do here is take the linear equation, which is x plus y is equal to 7. I'm going to rewrite this equation where we have one variable in terms of the other. Best practice is to take the variable that has the number 1 associated with it. However, in this example, we have x and y that have 1 associated with it, so it doesn't really matter. Therefore, just because I want to, I'm going to make this x is equal to and everything else. Therefore, I want to bring the y to the other side, so I'm going to minus y from both sides. This will leave me with x is equal to 7 minus y. Then what I do is I take my second equation, which is my quadratic, which is x squared plus y squared is equal to 25. And now, because I know that x is equal to 7 minus y, I'm going to replace the x squared in the second equation with what I know it is, which is 7 minus y. This will leave us with 7 minus y squared plus y squared is equal to 25. Multiplying out the bracket here, we get 7 minus y multiplied by 7 minus y plus y squared is equal to 25. That bracket is multiplied by going 7 multiplied by 7 minus y and minus y multiplied by 7 minus y plus y squared is equal to 25. Multiplying out the brackets, we get 7 by 7, which is 49, minus 7y minus 7y plus y squared is equal to 25. Adding the like terms here, we have minus 7y minus 7y and plus y squared. That will leave us with 49 minus 14y plus 2y squared is equal to 25. This is now a quadratic equation, as we have a y squared, a y, and numbers. To solve the quadratic equation, what we need to do is make it look like y squared plus y plus a number is equal to 0. To do that, I'm going to minus 25 from both sides to begin with. And that will leave us with 24 minus 14y plus 2y squared is equal to 0. I'm going to rewrite this so that the y squared comes first, the y is in the center, and we have the number at the end. Therefore, we'll have 2y squared minus 14y plus 24 is equal to 0. We can simplify this a bit further, and I'm going to move up here so that I have a bit more space. And we can divide everything by 2, as 2y squared, 14y, and 24 can all be divided by 2. The only reason why we can do this is because it's an equation. If this was an expression, we wouldn't be able to divide by 2. Dividing by 2 will end up with y squared minus 7y plus 12 is equal to 0. Then we solve our quadratic. Here, a is equal to 1, b is equal to minus 7, and c is equal to 12. I'm going to solve this using factors. So I'm going to multiply a and c. A is 1 and c is 12, which will give me 12 when they multiply by each other. Listing the numbers that multiply to give 12, well, we have 12 and 1, we have minus 12 and minus 1, we'll have 6 and 2, minus 6 and minus 2, we'll have 4 and 3 and minus 4 and minus 3. Now we have to pick the ones that when you add them together will equal the b, and the b here is minus 7. So 12 and 1 is 13, so it won't be that. Minus 12 minus 1 is minus 13, so it won't be that. 6 and 2 is 8, so it won't be that. Minus 6 and minus 2 is minus 8, so it won't be that either. 4 and 3 is 7, so we're close. However, we need it to be minus 7, so it's not that. And then we have minus 4 plus minus 3, which will give us minus 7, so we like what we have here. What I do then is I rewrite the quadratic, so y squared. But now, instead of writing minus 7y, I'm going to write minus 4y minus 3y, which is practically writing minus 7y. But we now have minus 4y minus 3y plus 12 is equal to 0. I underline the first two terms and I underline the second two terms. I factor the first two terms, so I'm going to take a y out of both and we'll be left with y minus 4. And I'm going to factor minus 3 out of the second two terms and we'll be left with y minus 4 on that one. As you can see here, we have the inside guys the exact same. So we have y minus 4 and y minus 4. That means we can write the inside guys together, y minus 4, and the outside guys together, y minus 3. That's all equal to 0. To finish this question, I'm just going to bring it up here as there's a bit more space. I'm going to rewrite what we have. So we have y minus 4 and y minus 3 equal to 0. That means that we have y minus 4 equal to 0 and y minus 3 equal to 0. So plussing 4 to both sides here, we'll get that y is equal to 4. And plussing 3 to both sides here, we'll get that y is equal to 3. Next, we can then find what x is equal to by substituting in what we know y is now. Well, x is equal to 7 minus y. So if y is equal to 4, we get 7 minus 4. So we get that x is equal to 3. And on this side, well, if y is equal to 3, we get that x is equal to 7 minus 3. So we get that x is equal to 4. Therefore, the answers for this question here are x equal to 3, x equal to 4, y equal to 4, y equal to 3. And what we've done here is we've solved the simultaneous equation x plus y is equal to 7 and x squared plus y squared is equal to 25. Example 3.2 asks us to solve the equations x plus y is equal to 3 and x squared plus y squared is equal to 17. To begin with any one linear, one quadratic simultaneous equation, we take the linear one and we write it so that we have it in terms of one variable. Here I have x plus y is equal to 3. So now I'm going to make it look like y is equal to everything else by minusing x from both sides. When I do that, I'll be left with y is equal to 3 minus x. Taking the quadratic equation then, we have x squared plus y squared is equal to 17. We now know that y is equal to 3 minus x. So I'm going to replace this y with what we know it is, which is 3 minus x. We'll then have x squared plus 3 minus x squared is equal to 17. 3 minus x squared is the same as having 3 minus x multiplied by 3 minus x. That then is just simplifying out the brackets. We get 3 times 3 minus x times 3 minus x. And that's equal to 17. Multiplying out the brackets then, we get x squared plus 9 minus 3x minus 3x plus x squared is equal to 17. Adding the like terms, we have a minus 3x and a minus 3x and an x squared and an x squared, meaning we'll have 2x squared minus 6x plus 9 is equal to 17. I hope that you can spot now that we have an x squared, an x, and a number, meaning we have a quadratic. However, if we are to solve this quadratic, we have to let it equal to 0. So I'm going to minus 17 from both sides. That will leave us with 2x squared minus 6x, and then plus 9 minus 17 will give us minus 8 is equal to 0. As all of the terms here in the quadratic are a multiple of 2, we can divide everything by 2. So I'm going to divide the 2 by 2, the minus 6 by 2, and the 8 by 2, which will leave us with x squared minus 3x minus 4 is equal to 0. Now I have the quadratic x squared minus 3x minus 4 is equal to 0. Next, I have to solve the quadratic. I'm going to solve the quadratic by factors. So a here is 1, b is minus 3, and c is minus 4. I'm going to multiply a by c, which is 1 by minus 4, which will give us minus 4. Writing then the things that multiply to give us minus 4, well, we have minus 4 and 1, or 4 and minus 1. We have minus 2 by 2, or we have 2 by minus 2. And then what we have to do is pick the one that when you add them together will equal the b. And remember, b is minus 3. Here we have minus 4 plus 1, which will give us minus 3. So luckily, we've picked the correct one first. We then rewrite the quadratic, but we replace the minus 3x with plus 1x minus 4x, and then write the minus 4 is equal to 0. We've basically done nothing here, as plus 1x minus 4x will give us minus 3x. So we've just written minus 3x in a different way. I'm going to underline the first two terms here, and I'm going to underline the second two terms there. I'm going to look at x squared and 1x, and I can divide an x out of both of those terms. When I divide an x out, I'll be left with x plus 1. And when I look at minus 4x and minus 4, both of them contain a minus 4, so I can divide out a minus 4, which will leave me with x plus 1. And that's equal to 0. Now, as I know my inside guys are x plus 1 and x plus 1, I can write my inside guys together, x plus 1, and my outside guys together, x minus 4. That's equal to 0. That means that I'll have x plus 1 is equal to 0 and x minus 4 is equal to 0. Leaving me then with x equal to minus 1 and x equal to 4. Now, I have my values for x, the minus 1 and 4, and I can use those values to figure out what y is. Up at the start, we figured out that y was equal to 3 minus x. However, now knowing what x is, if x is equal to minus 1, well then y is going to be equal to 3 minus minus 1, which will be y equal to 4. And if x is equal to 4, well then y is going to be equal to 3 minus 4, so y will be equal to minus 1. Therefore, I have my answers for this particular question. I have y is equal to minus 1, x is equal to 4, y is equal to 4, and x is equal to minus 1. Just to note that the linear equation might not look exactly like the way it is here with the x plus y is equal to 3, and the quadratic might not look like that either. Just to give you an example, they could give you a question such as x squared plus y squared is equal to 20, and x minus 2y is equal to 0. In this case, we make it so that it's x is equal to 2y. And if you notice the difference between this one and the one that we've just done, well, the other one, we had one variable is equal to another variable and some constant. However, in this one, we just have one variable is equal to a multiple of another variable. However, we do it in the exact same way. All you do here is you'd replace the x in the quadratic with what we know the x is, and the x is equal to 2y. Therefore, don't get freaked out if it doesn't look exactly like you've seen it before. Please do it in the exact same way by making the linear one have one variable on one side and the other variable on the other side, and then sub it in to the actual quadratic to figure out what the answer will be. The quadratic also might not look initially like a quadratic, and you could have something like xy is equal to 4 and y is equal to 2x plus 2. Again, this looks a little bit different, but you do it in the exact same way. The linear one here has already been changed first. We have y is equal to 2x plus 2. All you'd have to do then is replace the y in the quadratic one with exactly what we know y is. So you'd end up here with x times 2x plus 2 is equal to 4. Now this will create a quadratic straight away. We'd have 2x squared plus 2x is equal to 4, and then it just becomes solving the quadratic using either your minus b formula or your factors. So the main point to take away from this example at the end is just please don't get freaked out if you don't see it set up exactly the way it is in the questions in this video. Example 3.3 is an application. So it says here, find the points of intersection A and B of the line y is equal to 2x plus 3 and the curve y is equal to x squared. Now remember, what we've been looking at here is we've been looking at solving simultaneous equations where one is linear and one is quadratic. Mostly when we have a curve and it's in the form x squared, if we were to draw our x and y axis, the x squared would look like a U shape and would look something like this. The line y is equal to 2x plus 3 is a straight line. Any line is just a straight line, and it might look something like that. And all this is, or all we're trying to do in these questions, is find the points where these two parts intersect. Therefore, when we're doing the chapter on coordinate geometry of the line or coordinate geometry of the circle, we'll also be looking at these types of questions where lines and quadratics or cubics intersect and meet each other. Therefore, when we're given this question, we answer it in the exact same way as we would have. I'm going to write out here our two equations. We have y is equal to 2x plus 3, and we have y is equal to x squared. In this particular one, again, they've given us what y is. Y is equal to 2x plus 3. So I'm going to take that from the linear one and sub it into where y is in the quadratic one. Therefore, we'll be left with 2x plus 3 is equal to x squared. Now, I want this to be a quadratic. What I'm going to do is I'm going to let this equal to 0. And to do that, I'm going to minus x squared from both sides. And I'll be left with minus x squared plus 2x plus 3 is equal to 0. I find it much easier to work with quadratics when the x squared is positive. Therefore, I'm going to change all of the signs. And I can do this as it is an equation. If this was an expression, you wouldn't be able to change all the signs, but because it's an equation, we can. Therefore, this will become x squared minus 2x minus 3 is equal to 0. Again, I'm going to solve this with factorising. So my a here is 1, my b is minus 2, and my c is minus 3. We multiply a by c, which is 1 by minus 3, which gives us minus 3. And we have to list the things that multiply to give us minus 3. We've minus 3 by 1 and 3 by minus 1. We have to pick the one that when you add them together gives us minus 2, and that one will be minus 3 plus 1. Rewriting the quadratic then with the b changed, we get x squared minus 3x plus 1x minus 3 is equal to 0. Underlining the first two terms and the second two terms. Factorising the first two terms, you can divide an x out of both and you'll be left with x minus 3. And in the second one, we'll just divide a plus 1. So we'll get x minus 3 is equal to 0. Then this becomes x plus 1 multiplied by x minus 3, as here the inside guys, the x minus 3 and the x minus 3 are equal. Bringing that up here just so we have a bit more space, I have x plus 1, x minus 3 is equal to 0. As both of those things are equal to 0 when they're multiplied, they both must be equal to 0. We get x plus 1 is equal to 0 and x minus 3 is equal to 0. Minusing 1 from both sides, we get that x is equal to minus 1. And adding 3 to both sides, we get that x is equal to 3. Now that we know what x is, we should be able to use that to figure out what y is. At the very start of the question, we found that y is equal to 2x plus 3. Now that we have that x is equal to minus 1, well, we'll figure out that y is equal to 2 times minus 1 plus 3. 2 times minus 1 is minus 2. Adding 3 to that, we get that y is equal to 1. If x is equal to 3, well then y is going to be equal to 2 times 3 plus 3. 2 times 3 is 6, plus 3 is 9, so we get that y is equal to 9. Therefore, from this question, it says find the coordinates of the point of intersection A and B of the line y equal to 2x plus 3 and the curve y is equal to x squared. Well, we have x equal to minus 1, y equal to 1, x equal to 3, and y equal to 9. Writing these as coordinates, we get minus 1, 1, and 3, 9. That's another example of solving a simultaneous equation that has one linear, one quadratic. That brings this video of solving simultaneous equations to an end, but it's important to note that this isn't just algebra, this is also coordinate geometry of the line and coordinate geometry of the circle, which we'll be looking at later on in the year.